blood is a water-based solution of plasma and cells that work together to deliver oxygen, sugars, and hormones, to name a few, to each and every cell in our body to allow them to function properly. To be healthy, your blood must maintain a pH between 7.35 and 7.45, and even slight variations above and below these numbers can lead to catastrophic results. The pH of our blood is at risk of changing due to a variety of factors, but is most greatly affected by the amount of carbon dioxide in our blood. All of our body cells take part in a process called cellular respiration, which is a reaction that uses sugar and oxygen to produce energy, which we use, and gives us byproducts of carbon dioxide and water. In order for the carbon dioxide to be removed from our body, it is excreted back into the blood. When dissolved, the majority of it bonds with water in blood to form carbonic acid, which can further dissociate to create bicarbonate, a base, and hydronium ions, which decrease the pH of our blood. Our body works incredibly hard to make sure that we have the perfect amount of hydrogen ions in our blood to maintain its proper pH. Excess carbonic acid can be transported into our lungs, where it is breathed back out into the air as carbon dioxide. If our blood is becoming too acidic, meaning it has an excess of carbonic acid, and carbon dioxide needs to be expelled, our brain regulates our breathing to be more frequent and more deep, allowing more CO2 to be expelled through breathing. If our blood is becoming too basic, our body isn't really producing much CO2, our brain regulates our breathing to be more shallow and slow. On top of that, our kidneys play a part in controlling our blood's pH as well. If there are overly acidic or basic compounds in our blood, they will work to filter these compounds out of the blood and into our urine. But what happens if there's a sudden change in our blood's pH? That's where buffer systems come into play. A buffer system is a solution that consists of a weak acid and its conjugate base, or a weak base and its conjugate acid. In our blood, the weak acid is carbonic acid, and our weak base is its conjugate base, bicarbonate. If our blood were to become more acidic or have an excess of CO2, meaning there are more hydrogen ions in the system than at the initial equilibrium, our reaction would have more products than reactants. According to Le Chatelier's principle, hydrogen ions would be more likely to bump into the conjugate base and produce more carbonic acid, reducing the number of hydrogen ions and establishing a new equilibrium. This allows the change in pH to be minimal. If our blood were to become more basic or have too little CO2, meaning there are less hydrogen ions in the system than at initial equilibrium, our reaction would have more reactants than products. Our carbonic acid then would be more likely to dissociate into hydrogen ions and bicarbonate base, lowering the pH and establishing a new equilibrium. So, next time you go for a run, thank your lungs and a buffer system for keeping your blood at a healthy pH and you alive.